All right, here you go. Moving on to chapter 6.5. Hopefully you guys have recovered from your tough quiz that you took on Friday. I don't think, like I said, I think that most of you guys will be fine moving forward. And again, 6.5 is just a continuation of what we're doing. 6.5 is proving the triangles are similar by side, 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 and side, angle, side. Don't get this confused with triangle congruencies, side, 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 and side, angle, side. This is proving similarity using sides and proving similarity using side, angle, side. All right, so let's get started. So side, 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 similarity is that if two corresponding sides of two triangles, if the corresponding sides of two triangles are proportionate, then they are similar, which would be common sense. Okay, I believe that you guys understand that. But let's go ahead and take a look. So here, if triangle ABC is similar to triangle STR, that would mean that side AB here, side AB would be similar to side ST, how we have it written down here. Okay, and side BC would be similar to side TR, and then when you set those up as a proportion as we did here, okay, then they would be equal to one another. Likewise, in order for this to be completely true, then your side AC being similar to side SR would also have to equal. Okay, so basically if I set up all the sides with the small side equal to over the small side, and the medium size over the medium size, and the large sides over the large side, if I put those all equal to each other, when I work that out, they should all be equal to one another in order for them to be proportionate. So if that's the case, then you have side, side, side similarity. All right, so let's go ahead and take a look at an example with some numbers. Okay, here we have two triangles. We have triangle XYZ, and then we have triangle TUS, or however you want to look at it, STU, okay, if you go in alphabetical order. So if I want to prove that these are congruent, the first thing I want to do is set up the small sides together. So I have 15 over 15. Okay, so I'm going to take that small side, 15 over 15, and then don't be automatically presumptuous and assume that because 15 and 15 is not a ratio, because it is a ratio. It's a 1-to-1 ratio, and so it is possible to have a 1-to-1 ratio and then the sides be, and then the triangle be similar. Okay, a lot of times those turn out to be congruent triangles, and you can argue or make the assumption or the statement that congruent triangles are obviously and clearly similar as well. So let's go ahead and move on. So we have 15 over 15. We're going to set that equal to our medium sides. Okay, so if I'm looking at XYZ, my medium side or my middle side is going to be 25. Okay, and then I'm going to look over here at STU, and I'm going to see that my middle side is 20. And now as here we kind of break down. Here we have in this 15 over 15, we have a 1-to-1 ratio. But over here on the 20 to 25, it's not 1-to-1. If I was to reduce that, I would have 5 over 4, 5 to 4. Okay, so since these are not proportional, 15 over 15 does not equal 25 over 25, we can now make the similarity statement that says triangle XYZ is not similar. Okay, that kind of looks like an X, but I'm just putting a slash through that similarity sign, is not similar to triangle STU. If we would have gone out of order, you might have ended up with something like this, where you had 15 over 15. If we look at our large side is 30 over 30. In this case, we're still similar. We have to be careful to make sure we go ahead and do the other third side. And so then if I did the medium side last, I would have 25 over 20. Okay, these here, those work fine. But then you get to here and here, they don't work. Okay, all three sides must be proportional in order for this to work. So you have to be careful as not to be presumptuous, just to assume that because two sides work, the third one's automatically going to work, because it's not the case. It's not like angles where you have two angles that are congruent. The third one has to be congruent. Okay, so be careful with that. Okay, let's look at another example. What if I have the same triangle XYZ, and now I threw a different triangle with the PQR? let's go ahead and set this up. So my first thing is define the small sides. So I'm still looking at the 15 over, what's my small side on PQR? That's 21. So 15 over 21 is equal to my middle sides. So I have 30 on this, I'm sorry, not 30, 25 on this one here over my short one over here is 35, or my middle one over here is 35. Okay, now I can do one of two things here. I can cross multiply and see if they equal each other. So if I cross multiply, I have 15 times 35, and that gives me 525. And then 21 times 25 gives me 525. The other way I could do this is I could simply reduce 15 over 31. If I reduce that by 3, I get 5 over 7. 25 over 35, if I reduce that to its simplest form, I can reduce by 5, and I get 5 over 7. So that also proves that those two sides are similar. Okay, but then I can't stop there. I've got to go ahead and add in that third side. We're talking about our long side. And our long side for triangle XYZ is going to be triangle 30. I'm sorry, angle side 30 XZ. So that's going to be 30 over 42. And again, I can cross multiply and divide here and do 30 times 35. In this case, I have 1050. Okay, and then 42 times 25. And I'm going to get 1050 over here. And so these sides are proportional. If these sides are proportional, that means that these sides are also proportional. Again, if I wanted to do the reduction, which to me as always seems the easiest because I can reduce pretty much in my head, but if I reduce 30 and 42, if I reduce by 6, 30 divided by 6 is 5, and 42 divided by 6 is 7. So then my scale factor for all those is 5 over 7 equals 5 over 7 equals 5 over 7. So in this case, the similarity statement is going to be that triangle XYZ is similar to triangle PQR. Now, since XYZ is similar to PQR, we also know now that triangle PQR will not be similar to the triangle back on this page here, STU. Okay, so I know that two of them are similar and one is not. And since that one is not similar to the first one, it will also not be similar to the third one, so I can save us a little bit of time when we work out later. Okay, let's look at a different type of an example. Here, what we want to do is we want to make triangle MNO similar to triangle PQR. We're going to force that similarity. Okay, well, the first thing I want to do is I want to look for two sides that are together that we know, okay, that we know. And the great thing is earlier we said, okay, triangle PQR, or earlier we said we're going to take the small sides, put the small sides together, we're going to take the large sides, put the large sides together, and all that. We didn't know how the triangle was supposed to go. Well, in this case, because it's giving us the names of the triangles, we're going to know what order we go in. So M goes with P, N goes with Q, O goes with R. Okay? So that means that side MN over here is going to go with side PQ over here, which is great because now it sets me up with two sides with already given information. Complete. It's got an entire side completely done. So it's got 20 and 35. So I need to figure out what X value is going to make NO similar to, in this case, QR. Can't see the R over here, but that's what this is right here, QR. Okay. So what I need to do then is I took the small triangle, it's on top of the big triangle, and I'm going to take over here, I'm going to put that small number on top, which is X plus 6. And I'm going to put it on top of the side that it is similar to, and that is that QR, so that's 21. And now I can simply just solve this proportion for X. So I can do, and I'm going to set it up algebraically because we need to go ahead and practice that. So I'm going to do 21 times 20 and set that equal to, which is 420, and set that equal to 35 times x plus 6. Okay, if I want to go ahead and solve that out, I'm going to have 420 is equal to 35x You know what? I just realized something, and I sorry for the delay here. I made a mistake. I want to go ahead and keep in line with the notes that some of you guys print out, because I know that some of you guys print out notes on and follow along with your notes. And so with that being said, that side right there that I have marked as 35 should actually be 30. Okay, and I want to just make that correction so that way it follows directly with the notes that some of you guys are currently probably using. Okay, so that becomes 30 over here. Sorry, I hope that didn't confuse too many people. Okay, so now 420 equals 30x plus 30 times 6 is 180, and now I'm just going to simply solve for x. So I'm going to do 420 minus 180. That's going to give me 240 is equal to 30x. And when I divide both sides by 30, I'm going to get x equals 8. So in order to make triangle MNO similar to triangle PQR, x must be that value of 8. And if you want to test this, solving for 8, what we can do is we can also plug that 8 value back into this unknown side here and see if that works. So if that's 8, okay, 8 minus 2 is 6, so this side right here would be 24. Let's see if that lines up. Over here, this side is going to be 8 plus 6. This side is going to equal to 14. And so what I'm going to end up with, I'll put 24 here. Boy, my math is off. It's Sunday. I'm not feeling very well. Getting ready to go to church. So I'm struggling with my math. That should be 18. 6 minus 2 is 8. I'm sorry, 6 minus 2, 8 minus 2 is 6. 6 times 3 is 18. So let's see if that lines up. Okay, so I have small side being 12. And my small side over here being 18. What's the proportion 12 to 18? If I reduce this by 6, I end up with 2 over 3. Okay, what's my middle side over here? Yeah, 14. And my middle side over here is 21. So let's see what that does. 14 over 21. If I reduce that by 7, I get 2 over 3. And then my big side is 30 and 20. So if I put 20 over 30, I get 2 over 3. So 8 does work, and that was right here was just a way for us to check to make sure our answer was correct. Alright, so that's pretty much it for side, side, side. We're going to go ahead and move on to side, angle, side. Similarity, again, we're talking about similarity, not congruence. So side, angle, side similarity basically states that if two sides are proportional and the included angles are congruent, then they are similar. Again, included angles means this angle that is in between the two sides that are proportional. Okay, so let's jump right in to our first example. So here we have two triangles, and we see that we have two angles congruent right here, both of them in between the two sides that are given. So what we need to do now is to find out if the two sides are proportional. So I'm going to take the small one of 8 and I'm going to set it over the small one on the other triangle, which is 10. I'm going to set it equal to the next size, which is 12 over 15. And all I have to do to test proportionality is multiply 10 times 12. This comes out to be 120. Okay, 15 times 8, that also comes out to be 120. Since the 120 equals 120, you know that they're proportional. Since the two sides are proportional and you have a congruent angle in between that, you now can say those triangles are also similar. Again, another way you could do this, which is equally as easy, is you could say 8 over 10 equal to 10 over 15, and you could reduce 8 divided by 2 is 4 over 5. 10 and 15 divided by 5. I'm sorry, this is not 10, this is 12. Ali, I'm all over the place today. 12, not divided by 5. Instead, we're going to do 12 divided by 3 is 4 over 5. Okay? And since they both equal 4/5 in the reduced form, then they're also similar. So now you know they're similar. Our next example. Okay, here we have two triangles that are actually connected, or we have a couple different lines that create two triangles. Well, the first thing that we can do is we can tell that right here, these angles are congruent. Why is that? Yeah, that's because these angles are vertical angles. So those actually are the included angles. So what I need to do now is check for proportionality. Are the sides proportional? First thing I'm going to do is take my small side and put it over my other small side, which happens to be 15. Then I'm going to take my bigger side on the other triangle, which is 18, and put it over the bigger side from the one triangle, which is 30. And again, if I multiply 15 times 18, I get 270. If I multiply 30 times 9, I get 270. Since 270 equals 270, those sides are proportional. Because I have my included angles being congruent, those two triangles are now similar. Again, I could have done this in a way where I reduced by 3. So 9 over 15 reduces by 3 to be 3 over 5. 18 over 30, if I reduce this by 6, 18 divided by 6 is 3, and 30 divided by 6 is 5. And so since those come down and reduce down to the same, they are also congruent. And that's pretty much all you get with side angle side. Not a whole lot to that one, okay? So basically what we've learned so far is 3 ways to prove triangles to be similar. We've proved them to be similar using the angle-angle similarity, postulate, the side-side-side similarity now, and side-angle-side. All 3 of those things are stuff that you should know pretty well in detail. If you have any questions, as always, please write them down and come see me in the morning in tutoring, or you can come see me after school and pass, and we'll get that all worked out. All right, you guys have a great rest of your weekend, and I will talk to you guys on Monday.